All right, guys, lesson 101 is on geometric probability. So a little review on probability. Remember that it is favorable outcomes over total possible outcomes. So geometric probability really is the probability. You're going to be asked all these questions on what's the probability of hitting the bullseye here. So think of a dartboard. And to determine that, all you are going to have to do is find out what's the area of the bullseye and what's the area of the target. And you're going to put them in a ratio such as this, with the area of the bullseye over the area of the target, and simplify. All right, so pretty straightforward, pretty easy. Let's do a couple of examples. All right, so here's our first one. Let's find the geometric probability of hitting the inner circle. All right, so one thing of note is that with all of these, we are assuming that we are going to hit the dartboard. It's pretty hard to calculate the geometric probability of hitting the bullseye if we aren't assuming that we're going to hit the target as a whole. So we have to assume we're hitting this target. What's the probability of hitting the inner circle? So again, pause the video, see if you can figure it out. Here we go. I'm going to take the area of the inner circle. So I know the radius here is 2. So the bullseye or the inner circle is going to be 2 squared pi. Area of the circle is pi r squared, which is 4 pi for the inner circle. And then I'm going to do the same for the entire target, which has a radius of 4. So it's going to be 4 squared pi, which is 16 pi. So I simply put this in a fraction, 4 pi over 16 pi, and I simplify. My pi's cancel out, and 4 over 16 is equal to 1 over 4. So I have a 1 in 4 chance, or a 25% chance of hitting the bullseye here. All right, let's say that the target is actually much bigger. The bullseye stays the same, but the target is a lot bigger. All right, so again, I'm just going to find the area of the bullseye. So it's the same bullseye. So it's going to be 2 squared pi, 4 pi. But now my target is has a radius of 6, my board. So it's going to be 6 squared pi, which is 36 pi. I simplify here. My pi's cancel. I get 4 over 36. Which simplifies to 1 over 9. All right, pretty straightforward. Do 2 more. All right, so this time I'm just giving you the description of the dartboard. So it's a 16-inch diameter target with a 6-inch diameter bullseye. Go ahead, pause the video, see if you can figure this out. So here we go. I'm going to find the area of the bullseye first. So it's 6-inch diameter. So sometimes they try to trick you with this. So that's a 3-inch radius. So it's going to be 3 squared pi. Again, area of a circle is pi r squared, which is 9 pi. All right. My 16-inch diameter target, well, that's an 8-inch radius. So it's going to be 8 squared pi, which is 64 pi. Again, it's area of the bullseye over the area of the target. My pi's cancel, and I get 9 over 64, which does not simplify. You're welcome to write that as a fraction if you're using your calculator. I'm sorry, as a decimal if you're using your calculator. All right. Last one. All right, find the geometric probability. So this is a little different in that it's not maybe the same as like a standard dartboard. So the example in the book, I think, is that you're playing some game where you roll a die. What's the probability that the die, assuming it hits the target, the circle, lands in the square? All right, so you roll some number cube, and what is the probability that it's going to land inside the square if it hits the circular target? So all I'm going to do, well, pause it, see if you can figure it out. Here we go. So all I'm going to do here is find the area of the square and divide it by the area of the circle. So the area of the square is going to be 10 times 10, which is 100. the area of the circle, it's 20 inch, so this tells me it's a 20-inch diameter. So that means it's a 10-inch radius, so 10 squared pi, which is 100 pi, 100 over 100 pi, okay? So these cancel, leaving me with 1 up top and 1 below, which gives me an answer of 1 over pi. All right, so that's it for geometric probability, area of the bullseye or whatever you're trying to hit over the area of the entire target.